All right, when you're asked to factor with repeated use of the difference of square formula, that difference of square basically is something like maybe you'd have 4x squared minus 25. Okay, so this is a difference, so that's subtraction, and these are both squares. So basically I can break this down into 2x minus 5 and 2x plus 5. Okay, so you've done that previously if you've reached this topic, so I'm not going to go into that too deeply, so let's focus on how to use it a couple times. Now, whenever you're factoring, one of the things you want to do is always look for common factoring first, and I noticed that both of these terms have a y squared, so I'm going to common factor out the y squared, and that's going to leave me with w to the fourth minus 625. Now, what you're going to do here is, you notice you have basically the difference of two squares, but this is w to the fourth. But you're still going to break it down in the same way that we did the problem up here. Okay, so we're going to break this down into w squared and w squared. And then what times itself gives me 625? Well, that would be 25 times 25. And I need one of these to be plus and one of these to be minus. And I don't want to forget to bring down my my y squared here. I'm going to bring that down again. And then because I noticed that w squared minus 25 is the difference of squares, so I can factor this again using this difference of squares concept here. So I'm just going to bring down the w squared plus 25 as well, because if this is addition here, the sum of two squares is not factorable, but the difference is. Okay, so we're going to break this down into w minus 5 and w plus 5. Now, none of this can be factored any further, so this is the solution. Okay. Now, let's look at the other two examples here. So this second example, I see I can common factor out a 4. And I also notice that both terms have an x squared. So I'm going to take out a 4 and an x squared. And when I divide this by 4x squared, it's going to leave me with just a y to the fourth. So that's what I'm going to put inside of my parenthesis. Minus, and if I take 4x squared, divide it by 4x squared, I get a 1. Okay, and so now I look at this, and this is actually the difference of two squares. Remember, if I have a 1, I can always write 1 as 1 times 1. So this follows that same pattern, except for I'm going to break down this y to the fourth into y squared and y squared. And then the 1 into 1 times 1, and I need a plus and a minus. I'm going to put the minus first this time, doesn't matter. Okay, but just remember, you cannot factor the sum of two squares. But you can factor the difference of two squares. So y squared minus 1 I can factor again. So let's bring down the the 4x squared, and then factor this y squared minus 1 into y minus 1 and y plus 1, right? Y times y is y squared. A negative 1 times a positive 1 is a negative 1. Now, if you were using the distribution or the FOIL method, you would have ended up multiplying a negative 1 times y together and a positive 1 times y together. And if you would have done that, you would see that those cancel out. And so it's just going to leave you with, if you multiply these together, it would give you the y squared minus 1. Check it out if you're not sure. Okay? Don't forget to bring down the y squared minus 1, y squared plus 1, because it's not factorable any further. So, and this gives you the final factored form for this problem. Okay, now the third example here, this one, you can see how it's similar, but it's a little bit different. The first thing I'd do is see if I could divide 48 by 3. And if you find out what 48 divided by 3 is, it's 16. So I know I can common factor out a 3. And I see that they both terms have an x to the 4th. So I'm going to common factor out a 3 and an x to the 4th. And so if I divide this first term by 3x to the 4th, it's going to leave me with just a w to the 4th. Minus, and then let's see, 48x to the 4th divided by 3x to the 4th would leave me with just a 16. Okay, and then you just look at what you have here. This is w to the 4th minus 16. I can look at this as the difference of two squares. I bring down my common factor, break this up into two parentheses, and I'm going to separate w 4th into w squared and w squared, and 16 into 4 times 4, and I need a plus, and one needs to be minus, so that the middle terms will cancel each other out. Okay, now I can't do anything else to the 3x to the 4th. W squared plus 4 is factored as far as it can be factored. And then w squared minus 4 is the difference of two squares again. W times w gives me w squared, and 4, I can break that down into 2 and 2. And I need 1 plus and 1 to be a minus. And that's as far as I can factor that.